In practice, our projects might be very big and we might have several functions and we have several modules, codes here and there, and then there is a problem happened. You probably noticed a lot several times that there are a lot of lines of code in the, a lot of statements in the output board telling you about some lines of code for the exception. We actually call that stack trace or trace back or back trace, which simply refer to the function calls made in your code at a specific point. Remember, when we debug the functions, we have this stack of function calls. This is actually what we call a stack trace. The word stack is coming from a stack data structure, which follows something called last in first out. I would like in a minute tell you what is that, but if you didn't get it, this is totally okay. Let's say we would like to stack a set of books this way. I'll give you a book, you put it here, another here, third here, here. Now I asked you to give me a book. Which book you can easily provide it to me? The last one. That's why we call it last in, first out. It means that the last one to get here is the first one to get out. Thinking about functions, if function 1 call function 2, function 3, 4, 5, 6, 7. Now if there is a function that is done, it should be function 7 first, then function 6, then function 5, 4, 3, 2, 1. That's why we call it stack of function or stack trace. The trace help us mainly to know the exact line or file where the problem occurred, which is something very important for debugging. Let's try to see an example. I developed 4 simple modules and a script. The script is named program 1. It is importing module 1 and calling function 1 with value -10. Module 1 has a function f1 that is calling module 2 function 2. Module 2 calling module 3 function 3. Module 3 calling function module 4 function 4. Module 4 calling the math.square-root module. Now the x with -10 is jumping from function to another till here. When you compute math.square-root x, when x is minus value, it will fail. The reason in math is the -10 is out of the domain of values that are valid for the square root function. So the word domain here is coming mainly from mathematics, because you will notice in the error message there is a problem about the domain of the value. Now we run this program. How can I figure out among all of these modules? Through the stack trace. This is the error message that you will see. You will notice there are file, and then in the last line here, observe there is something saying value error, math domain error. So now when you see, this is what we call stack trace. We have all of the files and all of the line of codes and all of the functions that cause the problem. The way that you start understanding this file is by first looking to its end, value error. So now you know where is the problem. In the line before it, you see math.square-root x. This is the first position where the problem happened. It happened in module 4, line 4, in function f4. Then it's actually, this call was coming from line 4 f3, then from line 4 f2, then from line 4 f1, then from line 3 in this call. Observe all of them are 4 just because they are all here in 4, but if you change that, they will be in different file lines. So this is what we call a stack trace. It has all of the function calls till the problem happened, and you start typically from the end of it, not from the front of it. In some very complicated scenarios, you might find some useful information in the middle of the calls. This happens a lot in maybe things that involve the threads. In machine learning, I meet that a lot. But for simplicity for now, it will be for you very straightforward, the stack this way. And observe, we here code f1, f2, f3, f4, then the square root function, but the stack trace will be f4, f3, f2, f1, following the LIFO principle, which is last in, first out. In Python 2, the stack trace was very limited, but in Python 3, we have all of this chain of information. That's all.